Okay. Hello. I'll be revising spec again, yeah? I'll be doing vectors and like a bit of proofs. Okay, vector proofs, but it's like more vectors than proofs, I think. Oh well. Let's start with the question. It's like one question. It's like decently hard. It's like not that bad. But it's like a question that I can give you in exams, yeah. Okay. So the question says in triangle ABC, D lies on side AB such that wait, AD DB equals to 1 to 2. And then E is the midpoint of AC. And then let AB equals B and like, oh my god, AC equals C. Let's draw that. Random triangle. It's a very bad triangle. Let's make it bigger. Yeah, okay. A, B, C. So A, D, D, B, yeah. So it's in between A, B. So now AD is 1. So D is like here. 1, 2. And then E is the midpoint of AC. So E must be here. And then AB is B. I'm too used to A and B. C. Okay. And the first part asked us that by assuming P, by assuming P lies on the segment BE, wait, oh, we missed a part of the question. It says the line segments CD and BE intersect the internal point P. Okay, let's draw CD. Oh, well, that didn't work. Okay. What is that? Okay. CD and BE. And they intersect at P. And by assuming P lies on the segment BE, such that BP equals lambda BE. And then express the position vector of AP purely on the terms position vector AP. Oh yeah, because they're using A as the origin, which is normally O, and that's weird. And it says I have to express AP in terms of B, C, and scalar lambda. Oh well. So AP, AP, we have to use BP or BE, yeah. So BE will definitely not get us to P because it just goes over P. So we're definitely gonna use BP, and that's what they want. That's what this is for. So to use BP, to get AP, we have to do AB plus BP. So AB plus BP. Now sneezing. BP and okay. So yeah, AB, because AB is B, we can just write B, vector B. And then BP, as we stated here, is just lambda B E. And that will equals to B plus lambda BE, yeah. BE is just BA AE. So that's just negative B plus a half C. So negative B a half C. And that equals to B minus lambda B plus a half lambda c. And now we want part, yeah, that's it, because we can't simplify this more, so that's it. And we want part b, and part b says by assuming p lies on this line segment CD such that dp is mu dc, express the position vector ap again. Okay, so the structuring like that to get us to the final point where we find out what lambda and mu is, which is a normal question, and they give that in tests to test people, simultaneous equations, and this is normally in Calc 3. So yeah, let's do that. So AP, let's write the thing first. So it says dP equals mu dc. Okay, so dP, so we should use dP. So that's literally just a third of AB. So let's just write AD, yeah? AD plus AD plus DP, yeah, to get AP. That's very valid. So we want DP. And that leads us to 1/3 of B plus dP, which is mu dc. And that equals to 1/3 B plus mu dc. What's dc? dc is negative 1/3 B plus c. So negative 1/3 B plus c. And we can expand it out like 1/3 B minus 1/3 mu B plus mu C. And that's it, because we can't simplify more. And for part C, for part C, it is, for part C, it's obvious that we have to equate them. So the question literally says use the principle of linear independence. They normally don't say this in tests. You just know what to do. Yeah, equating coefficient of B and C, calculate the exact values of lambda and mu, hence the exact geometric ratio in which P divides the line segment BE. Okay, so first let's just equate these two. I don't have memory, so I'm just gonna copy and paste it. Frick, it's not good. So basically, this thing equals AP, and then this thing also equals AP. That means B minus lambda B plus 2 lambda C equals 1/3B minus 1/3 mu B plus mu C. So now what we can do is we can take out all the B's. So basically we can treat it as a normal column vectors, right? So this is just, if we say B is on top, C is on bottom, just 1, 0. So then if 1, 0 take away like 2, 0 equals something, this must be -1 something, and if this is something as well, yeah. So then that's what we can do for these kind of ones, and this is what is called a linear independence. I've never seen that word, because we don't have that in our tests, because they just say, oh, find lambda and mu, yeah. Okay, so let's just do it, yeah. So it's just 1 minus lambda equals 1/3 B. Wait, we're not doing B anymore. Minus 1/3 mu. And let's just write out C first. Let's leave some space because we gotta rearrange it to do simultaneous in Calc 3. So C is just 1/2 lambda equals mu, because there's only 2 C's, and that makes it easy. And because there's a coefficient in front of mu, it'll be hard to rearrange. So we're just gonna do it to lambda, yeah. So this is just lambda. Well, okay, let's just do the whole thing. Okay. Negative lambda equals, well, you take 1, so it becomes negative 2 over 3 minus 1 over 3 mu, and then to cancel out the negatives, this will be a plus. And now, this is still not it, so we have to do lambda equals 2 mu. And then we can equate these two, this one and this one. We get 2 over 3 plus 1 over 3 equals 2. And then 2 over 3 equals, well, divided by 3, so this just equals to 6 over 3. So then if you subtract this to this side, it becomes 5 over 3. Mu equals 2. We just flip these two and the 3 and then time to this side. So 3 and 3 will cancel out. 5 will go on the bottom, so it's 2 over 5. And we do need to find the other one. So this equation is really easy, so we're just going to do it. So lambda is just 2 times this. So 2 times 2 is 4. So lambda must equal 4 over 5. And that's part of the question. The next part of the question, and hence state the exact geometric ratio in which P divides the line segment BE. Yeah. So for that to happen, we have to use this, and also this. Oh, BP, and then BP equals lambda BE. And now we know that lambda is the number we have. And we want it so that P is in the middle. So that we normally put ratios as in, like, for example, AB is centered by C. Yeah, we'll do AC, CB. Yeah, because right now it will ask us how is C cutting the line. So we want to do it in that form. So our original line is what is it? It's BE. Yeah, it's the original line is BE, and then P cuts through it. So we'll do it in the order of BP and PE. So we have BP equals this thing. That means PE must equals to, well, BE, because that's the full line, minus BP. So that just equals to 5 over 5 BE. Take 4 over 5 BE, which equals to 1 over 5 BE. And now we can do BP ratio with PE, and that's just 4 over 5 BE and 4 over 5 BE and 1 over 5 BE. So that is just 4 to 1 because they're both divided by 5. And that's it for this pretty decent question. It can get harder in exams. This would be, I would say, a 4 to 6 mark question. Yeah, it's not gonna be one of the last ones, but this is gonna be a pretty important question you get in Spec. So learn this. Yeah. All right. Bye bye.